Hey guys, welcome to lesson 11.3, your flipped classroom for tonight. We are going to be, after tonight, we're going to be more than halfway through the final chapter in our book. And we're going to look at shapes of distribution. And you were kind of introduced to this today in class with our box and whisker lesson when we talked and looked at whether the left whisker was longer than the right whisker or if the two whiskers were symmetrical. So the essential question for tonight is how can you use a histogram to characterize the basic shape of a distribution. Now look at the definition. For those of you familiar with the histogram, it is a bar graph, but you're going to notice the difference in a histogram and a regular bar graph. The bars are actually going to be touching when you're doing a histogram. Okay, that's not the case when you make a regular bar graph, but for a histogram, the bars are going to be touching, and it also shows frequency of data values in intervals, all right? So we're talking about intervals of 5, intervals of 10, intervals of 20, just depending on the data that we're given. But it's also important to note that you must have a frequency table before you can create a histogram. So before we can ever draw a histogram, we have to have a frequency table. So if they don't give us one, then we are going to have to create one. But before we even get to that, let's look at the symmetric versus the skewed distributions. And again, this should look familiar to you based on what we did today in class with the box and whisker plot. You have first a histogram that is skewed left, because if you look at it, the tail of the histogram is longer on the left. So this histogram is skewed left because most of the data is on the right. So before you let yourself get confused, you're looking for the longer tail. If you need to tell whether it's skewed left or right, you're finding the tail that is longer. Because if you look in the middle, this is a symmetric histogram. All right, both sides, both tails are very even. All right, so the data on the right of the distribution are approximately a mirror image of the data on the left of the distribution. That's symmetric. And then lastly, if you look at the histogram that is skewed to the right, again, you can see the tail of the histogram is longer on the right, which means that most of the data is on the left. But again, when you're trying to figure out if it's skewed right or if it's skewed left, look for the longer tail. Now, you're also going to see a question asked to you saying, choose the appropriate measures. Yesterday, we learned the measures of center and we learned the measures of variation. If you remember the measures of center, we had the mean, the median, and the mode. And then for your measures of variation, we had range and standard deviation. So when, and I would grab my highlighter and I would highlight this, when the data is symmetric, you use the mean to describe the center and you use standard deviation to describe the variation. Now you're not actually going to have to find the mean and the standard deviation, but you need to know if my data is symmetrical, the mean would help me describe the center of my data, the standard deviation would help me to describe the variation. Because look what happens when my data is skewed. If my data is skewed to the right or the left, it doesn't matter, I'm going to use the median to describe the center. The median is going to be a better representation of my center, and I'm going to use the 5-number summary, which if we dig a little deeper, that would be the 5 values that we found today for our box and whisker plot. But again, you're not going to have to actually find the median and the 5-number summary. It's just knowing that if your data is skewed, the median would help you describe the center best, and the 5-number summary would help you describe the variation the best. Now, let's draw some histograms. If you go to example number 1, it says, display the data on a histogram and describe the shape. So you can see the problem has given us that frequency table that we talked about needing. So really we just have to create the histogram. So here's where I would start. I would go ahead and draw a line at that will be the bottom of my histogram, and then I'm going to go ahead and write my intervals. So we've got 1 to 10, maybe leave a little bit of space before I do 11 to 20, a little bit of space before I do 21 to 30, a little bit of space before 31 to 40, a little bit of space before 41 to 50, and then a little bit of space before the 51 to the 60. Now this just allows me to extend that line a little bit longer. And then next I'm going to draw this bar up the left side, because this is where I'm going to decide what intervals I want to count by that are going to represent these frequencies. So if we look at my frequencies, I can see that my smallest one is a 7 and I can see that my largest one is a 34. So I've got to decide which frequencies or which intervals would be the best. Now, based on my smallest number and my largest number, I'm going to go ahead and count by fives. So I'm going to put a 0, and then I'm going to put a 5, and then I'm going to put a 10, a 15, a 20, a 25, a 30, and of course my largest number is 34, so I'm going to have to go to 35, which will cause me to extend that a little bit longer as well. Now I have to label. What do the intervals represent? They represent the number of pounds. So I'm going to put that label on the bottom. All right, we know the side, the numbers going up the side represent the frequency. Okay, and now I just have to draw my bars. So for interval 1 through 10, I had 7. So I'm going to go just a little bit above that 5, and I'm going to draw a bar over. I'm going to draw a bar down, and I'm going to ask you to label on top of that bar what your frequency is. That way I know exactly what you chose as your frequency. 11 to 20, the frequency is an 8. So I'm going to go just a little bit above that bar I just drew, make the bar on the right an extension a little bit, draw it over and come down. I'm going to try to do that a little bit neater, and then I'm going to put an 8 on top. All right, the next one is a 10. So it gets a little bit tricky. Should probably go back to this one and just do it a little bit different. We're going to go 7. Okay. We're going to go 7. We're going to go 8. We're going to go a little bit higher to 10. Okay. 31 to 40, that frequency was 16. So we're going to go, and let's make this a little bit, again, it's just kind of trial and error based on how far apart you spaced your intervals. All right, 16 is the next. So we're going to extend this bar up a little bit past 15. Draw it over. We've got 16. All right, our next interval is 34. So this one takes us all the way up here, almost to the top. Draw our bar over. Of course, we're going to sit that 34 on top. And then our last interval, 51 to 60, only went up to 15. So we got to make sure we're just a little bit below that 16 and draw our 15. All right. Now, by numbering the top of our bars, that kind of helps too. If our bars are not exact, we know what numbers we intended to represent. Now, we can finish this. We can draw this box the rest of the way up. We can come all the way across, and we can close our histogram. Let's make sure that when we do it, we are closing right on, okay, our bar's got to be touching the very end of our histogram, so we'll have to make a few adjustments there. All right. Now, the question we're supposed to answer once we've drawn this histogram is describe the shape. Is it symmetrical? Is it skewed to the right, or is it skewed to the left? And if you were to draw kind of that bell curve and you were to draw it over that tallest point, you can see that the tail on the left is longer than the tail on the right. So this makes our histogram skewed left. Okay, so describing the shape is just telling that it is skewed to the left. Now go ahead and pause and draw your own histogram for letter B, and then come back and see if it matches up with mine. Again, we were given a frequency table, so it becomes a matter of drawing that bottom and just drawing out those intervals. So 1 to 8, 9 to 16, 17 to 24, 25 to 32, 33 to 40, 41 to 48, make that line a little bit longer, and 49 to 56. Now, if we look at our frequencies, we see that our smallest number is a 5 and our largest number is a 25. So again, counting by 5s would be a perfect interval. So 0, 5, 10, 15, 20, and 25. Okay, so 1 to 8 was 5, so we draw our first bar, set a 5 on top. 9 to 16 was 9, so we're going to go a little bit higher, not quite to the 10, to 9. The next interval was 16, so we go just a little bit past that 15. Mark 16, 25. Our next interval, the 25 to 32, is 25, so we're going to extend that all the way up to the top. Draw that over, set that 25 on top. The next interval was a 20, so we're going to make that bar 20. The 41 to 48 was an 8, so we're going to go just a little bit underneath our 9, make that an 8, and our last interval was a 7, so just below the 8 to the 7. Okay, we'll close up that histogram, bring it straight down so it touches, and then don't forget to label. Okay, this is the number of tickets sold. And of course, again, the numbers on the side are just your frequency. So we label that with the word frequency. Now, if we want to draw that bell curve, or if we just want to eye it, either way, we find that center, we make that little bell curve, and you can see that the tails on either side are about the same. So that makes the distribution symmetric on letter B. Now, hopefully you took the time to pause and figure that out, and you're just checking against mine, but that is a histogram. Now, example number 2 still wants us to display the data in the histogram, but then they want us to answer the question. So you're going to notice, hopefully right off the bat, that letter A is just a bunch of numbers. There is no frequency table. So the first thing that we're going to have to do is we're going to have to create our own frequency table. So we're going to put emails. We're going to put frequency. And we're going to abbreviate, and then we're going to put totals. Because once we put all our little frequency marks, we're going to have to add them up and get our totals. All right, so I've told you to use 6 intervals and start with 1 to 20. So our intervals are going to be 1 to 20, 21 to 40, 41 to 60, 61 to 80, 81 to 100, and 101 to 120. So we're going to extend our lines, and these are going to be our intervals. So we're just going to extend lines. We're making our own frequency table. Now, this means we go through and we just put a tally mark next to the interval that the number falls into. So, for example, number 74 falls in the 61 to 80 interval. 85 is between 81 and 100, and so on. So we've got 65, 64, 72, 42, 105, 75, 55, 52, 5, 25, oh no, these are getting 25, 98, 60, 58, 65, 45, 95, 68, 48, 45, 30, 77, 16, 64, 51, 38, 70, 83, and 120. So now we just count up the tally marks. There's 2 there, there's 3 there, 9 there, 10 there, 4 there, and 2 there. So we've made our own frequency table. Now we're going to make our histogram. So once again, we're just going to do these 2 outside pieces, and we're going to put our intervals, 1 to 20, 21 to 40, 41 to 60, 61 to 80, 81 to 100. We're going to squeeze that 101 to 120 onto our screen, and we're going to extend it. All right, our smallest number is a 2. Our largest is a 10. So counting by 2s would work here. So we're going to count 0, 2, 4, 6, 8, and 10. We're going to label frequency. And we're going to label email attachment sent. And now we draw our bars. Our 1 to 20 interval only had 2. Our 21 to 40 had 3, so we're going to go a little bit higher, draw our 3. Our 41 to 60 had 9, so we're going to go up here a little bit past that 8. Our 61 to 80 had 10, so we're going to extend that a little bit. Sorry about that. 68 to 10. Our 81 to 100 was back down to 4. And lastly, our 101 to 120 was back down to 2. So we've got our histogram drawn. And we can finish extending that bar up, bringing it over, and closing our histogram. And then we're going to answer the question, which measure of center and variation best represents the data? Well, again, if we draw that bell curve, hopefully you can see that those tails are pretty much symmetric. So if our histogram is symmetric, then according to our notes, which measure of center is the best? When the histogram is symmetric, we use our mean to find our measure of center, and we use standard deviation to find the measure of variation. So the answer to our question, based off of our histogram, is the mean and the standard deviation. Now that's lesson 11.3. If you've got great drawing skills, this is going to be a fun lesson. If your drawing skills aren't so great like mine, you might struggle a little bit, but that is okay. Now before you close this up, I want you to go back to example 1, letter A, and I want you to tell me what you did for Easter. Have an awesome night, and I will see you tomorrow.